what's up? Welcome to TCK Tutorials, and this is FPS 1.13. In our last episode, we learned how to create a bullet a certain number of times per second in the correct placement and rotation of where we want the bullet to shoot. Now we actually have to make the bullet shoot and create a bullet hole. While it's going to look like the bullet's shooting, technically our game object isn't moving anywhere. It's going to stay exactly where it is when we create it, but what we're doing is we're creating a raycast. So what a raycast is basically it shoots a ray or an infinitely skinny line in a direction. So it's kind of like a laser pointer. You point a laser pointer and then it creates a red dot where it hits something. But in our case, instead of a red dot, we're creating a bullet hole. So yeah, let's pull up our variables and let's get started. So our first variable is max dist. This stands for maximum distance. So this is going to be the maximum distance that our raycast is going to be checking for collisions. So if this is 1,000,000, it's going to go out for 1,000,000 units before the raycast gives up and stops looking for collisions. But if we set it to 1, it's only going to go out 1 unit. So if we set it to 1, it's only going to go out probably, the length of your arm, and then that's not a very useful bullet because a bullet only shoots the length of your arm. That's kind of pointless. But we just have this variable in place just for if you have a slower computer. It takes a little bit of memory to do raycast, and it technically has to check every collider and object in the scene in order to shoot that raycast. So if we don't want it to shoot as far, it could save us processing power and our game would run a little bit faster. But for now, we might as well start it off at a number really high, like 1,000,000 or 1,000,000,000, and then make it go smaller from there until it runs fast. For right now, we're just shooting a couple of bullets a second, so hopefully it really shouldn't take up too much processing power, and we can just leave this number at a really high number like 1,000,000,000, even if you have somewhat of a slow computer. Okay, and then our next variable is decal hit wall. So this is, remember in our last tutorial we had bullet. So that was a prefab that we had saved that we could copy at any time into our scene. We're doing the same thing with decal hit wall, except decal hit wall is going to be saving the bullet hole, and we're going to create a decal that's going to float in front of the wall that we hit. So what we're going to technically decal hit wall is going to be a game object that we're going to save as a prefab, and this game object is going to be a two-dimensional plane. So it's just going to be this 2D square that we can place anywhere in 3D space, and we're going to put a texture on it of a bullet hole. So yes, that is decal hit wall, and then we have float in front of wall. So when we create the decal or the bullet hole, we don't want it to be directly on the wall that we shoot, because if we do that, the textures of the wall and the bullet hole are going to mix together in kind of a digital way, and it's going to get all jaggedy and it's going to look really bad. So what we want to do is we want to take that bullet hole and have it float in front of the wall ever so slightly, just a little bit, just so that so it doesn't look like it's floating off the wall, but technically it is, so the textures don't mix together. So we can change this number to a really small number or a slightly larger number depending on how the game looks. So if bullet holes really far in the distance are getting kind of glitchy and mixing with the texture of the wall, we can make this a slightly larger number, but we don't want to make it too large where you can actually see it floating off the wall. We just want to float off the wall just a tiny bit, just so the textures don't mix with each other. So those are the 3 variables that we're going to be using inside of this script, and here is the script itself. Gotta resize my window. Okay. So this whole thing is going to be inside of a function called function awake. So this is kind of like function update, or what I've been calling the update loop. Except it only is run when the game object is created. So don't get this confused with function start. Function start only runs when the game itself first starts, or the scene itself first starts. Whereas in our case, the bullets aren't going to be created until a few seconds into the game or a few minutes into the game when the player first shoots a bullet. So we want this function to run when we first create the bullet. So this all of this code is only going to be ran once when the bullet is created. So the first thing we have is we're creating a variable called hit, and it is of type raycast hit. So what raycast hit is raycast hit is a type of variable that saves a whole bunch of information about a raycast when it hits something. So this can be the game object that it hit, the collider that it hit, the point in 3D space that it hit, the normal of the collider, or the normal of the face that it hit, so the direction of the surface, the direction that the surface is pointing that the raycast hit, and there's a bunch of other things that we can get out of the raycast hit. So what we're going to do is we're going to create a raycast inside of an if statement, and we're going to save all that information inside of the variable hit. So let's go over that. So we have an if statement with an opening bracket here and a closing bracket here. So if this returns true, it's going to run all this code here. So we have if physics.raycast transform.position transform.forward hit and max dist. Physics.raycast is a function that actually shoots a raycast and returns and it's going to return all the information about that raycast inside of the variable hit, or whatever variable we define here. And when you put physics.raycast inside of an if statement, it's going to return true or false depending on whether or not it hit something. So if we're aiming at a wall and we shoot a wall, it's going to return true. If we're aiming at the sky and we shoot at the sky, it's going to return false because there's no objects in the sky, so it's not going to hit anything. So there's a couple of parameters for physics.raycast, and the first one is the origin of the raycast, or where we want the ray to start. So if we imagine the raycast as a laser pointer, it would be wherever this laser pointer is going to be in 3D space, and this is saved as a vector 3. In this case, we're doing transform.position because the bullet has been created right in front of our gun, pointing in the direction that we want. So the bullet is already where we want the ray to start. So we're just going to do transform.position so the ray starts exactly where the bullet is now. The next is the direction that we want the ray to go. Now you would think that this would be a quaternion, but actually it's a magnitude vector 3. So what a magnitude vector is a vector with a magnitude of 1 that shows direction rather than a point in 3D space. So if you imagine a vector 3, you have an x and a y and a z, and depending on the 3 numbers that you give it, you're going to get a point in 3D space. And if this only has a magnitude of 1, this point, or the resulting point, can only be a distance of 1 away from the origin of 0, 0, 0. So when we put it somewhere inside of there where it's only a distance away, or distance of 1 away from 0, 0, 0, we get kind of a pointing direction. So if the 3 numbers result in it being here, we're going to be pointing in that direction. But with a magnitude vector, we don't get this twisty motion right here that you can get with quaternions. But with raycasts, we don't need that. So if you imagine a laser pointer again, you're pointing it this way, and then you decide to twist it. The laser is still going to be in the same position and look exactly the same because it's a laser pointer. It doesn't matter if you twist it. It just needs direction. So that's the exact same thing with a raycast. It doesn't matter how it's twisted. It just needs to go in a certain direction. So in this case, we have transform.forward. So what transform.forward is it's a magnitude vector that tells where the forward direction is for that particular transform in regards to how it was rotated. So if our transform is rotated and it's looking this way, forward is going to be that way. If it's looking this way, forward is going to be that way, and so on and so forth. So that is what transform.forward is, and that is going to be the direction that we want the raycast to go, because our bullet has been created in the position and rotation of the bullet spawn, which is in the position and rotation that we want the bullet to go. Next we have hit, and inside of here we can put any raycast hit variable. In this case, we have hit, which is the variable we defined up here, and it is of type raycast hit. So we're going to store all of our information about this raycast into here so that we can access it later. And then we have max dist, and this is the maximum distance that the ray is going to go for before it gives up and stops looking for collisions. So the smaller the number we make this, the faster the computer is going to run. And the larger the number we make it, the farther this raycast can go. If we were to leave this blank, it would just by default be infinity, which for the most part should be fine for most computers. I don't think it's really going to be that much of a concern for this game, even if you have a slow computer, so I wouldn't worry too much about that, and I would just set it to a really large number and just forget about it. So we have that raycast inside of the if statement, so if our bullet hits something, or if the raycast detects a collision, it's going to return true and run all of this code. So, and we have an if statement right here that has two parts to it. First, we have decal hit wall. So if you remember in our last episode, we did the exact same thing with if bullet. So in this case, we have if decal hit wall. So if we defined what the bullet hole is going to be, or what prefab we want the bullet hole is going to be, and we save it inside of the variable decal hit wall, it's going to return true. If we didn't assign it to anything, it's going to return false. Okay, and then we have and, which means both stupid highlighting, both this statement and this statement have to be true for the whole thing to be true and to execute the next line of code. So we have hit.transform.tag equals level parts. So remember, hit right here is this variable here, which we have stored all of the information about the raycast into. So under hit, or the raycast hit, we can access what transform was attached to the game object that we hit, and then we can access the tag of that transform. So if you don't know what a tag is basically a string that we can attach to any kind of game object, and it is in the inspector. It's listed under tags, and you can have a list of tags in your game, and this can be water, player, enemy, bullet, health pack. So the list goes on, and it's just a nice, quick, easy way of figuring out what type of game object we're actually referring to. So we can use tags for just about anything, and in this case we have level parts. So these are going to be all the different parts of the level, whether that be the floor or the terrain or the walls or the ceiling or the buildings or sidewalks or anything you put inside of the level. We're going to give it all the different level parts a tag of level parts. So that way we can take the tag from the hit and see if it's a level part, and if it is, we'll create a bullet hole with this line of code here, which is another instantiate function. So remember in our last episode, we instantiated a bullet at a position and rotation. So we have instantiate and we have decal hit wall. So this is the prefab that we're going to save in the inspector. So we know what prefab is the bullet hole, and we know what game object to create. And then this here is the position that we want to create it at. And we have hit.point. So remember, raycast hit and point is the point in 3D space where that collision actually happened. So this is where we're going to want to create the bullet. Next, we need to have the bullet float off of the wall just a little bit. So then we're going to have in parentheses here, and we're adding to hit.point, hit.normal. Now hit.normal is a magnitude vector that is going to show the direction that the face is pointing that we hit. So, you know, here's part of a game object, here's our raycast, it hits, here's our hit.point, and then our hit.normal is going to be this way because it's showing the direction that our face, or that the face that we hit is pointing. We used the exact same thing early on when we were trying to detect the floor and whether or not we can jump. We were comparing the normal of the floor and whether or not it is pointing up or at a 45-degree angle, and we were comparing angles a few episodes ago. So that is what the normal is, and that has a magnitude of 1. So that means if we were to just do hit dot point plus hit dot normal, it would float off the wall at 1. Or it would float a unit of 1 away, but 1 is too much. You'll be able to see that, and you'll be able to see the bullet hole floating off the wall. So we're going to multiply this whole vector 3 right here by float in front of wall, which is probably going to be a number like 0.001. So we're going to make hit.normal a lot smaller so that it floats off the wall just a little bit. So that is the position that we want to create the bullet hole at. Next, we need to define the rotation. And this is going to be in a quaternion. So we're going to use a function under the quaternion class called lookRotation. So we have quaternion.lookRotation hit.normal. So what lookRotation, it is what it sounds like. It's creating a quaternion out of a rotation based on if you were looking somewhere. So what you would do is you would give a magnitude vector to lookRotation, and it's going to create a quaternion out of a magnitude vector. So remember, a magnitude vector can point in a direction, but it doesn't have this twisty rotation like a quaternion does. So what it's going to do is it's going to create that twisty motion itself, depending on whether or not we give it the next parameter. So if I wanted to, I could write vector 3 0 1 comma 0. So the next parameter I could give it is a vector 3, but if I don't do that next parameter, it's gonna by default just give it a vector 3 that's pointing straight up. So basically, if you think about lookRotation, think about your head looking at something. So let's say you want to look in that direction. You're going to look over and up, and you have this, your shoulders and your body and your neck have this upwards motion. So that's up. So you would like go around up, and then you look at what you want to look at. So that's how it creates this rotation. So let's say you were Spider-Man and you're on a wall and your head is sideways. You're going to want to have up be in that direction. But for our case, we could just have up be the default up. So we can delete this whole vector 3 thing. And it's just going to, basically, in short, it's going to turn hit.normal into a quaternion because we need a quaternion for the rotation of where we want to spawn the bullet hole. Alright, sorry about that, guys. My camera cut out because I was recording for too long. But to finish explaining about the vector 3.up and the lookRotation, basically, long story short, quaternion.lookRotation is going to turn hit.normal from a magnitude vector into a quaternion, because for instantiate, we need the rotation to be in a quaternion because the roll twisty motion does matter, because we need to know the exact rotation to create our game object. So it's just going to use the default up, but for the most part, you just need to know that we're just turning hit.normal into a quaternion. So that is next. Okay, so next we got to go over destroy game object. So we don't want these bullets to linger around forever because they're just going to keep adding up, and we're going to have this long list of bullet game objects inside of our scene, and that's just going to slow things down. And bullets aren't going to do anything after they shoot for the initial time. So after we're done with them, we might as well just delete them. So at the end of all this code, we just have destroy game object. Now, destroy is a function inside of the class game object, but we don't need to write game object because we are already inside of a game object. And what we are going to destroy is game object in lowercase. So when it's lowercase like that, that means we are referring to the game object that this script is attached to. We're not referring to the class game object, we are referring to the variable, and that variable is the game object that we are attached to. So it's going to basically destroy itself at the end of all this code. So yeah, that is all you need to know to have the bullet shoot and create a bullet hole that floats slightly off the wall and then destroy itself when it's done. So now I'm going to cut the green screen and go onto the computer, and I'm going to show you how to do that inside of Unity. Alright, here we are inside of Unity, and I want to do a couple of things first before I actually get started. So the first thing I want to do is let's create some tags so that we can actually tag the level so that our bullets actually know what they're hitting. So first let's start with the ground. Right now it is untagged, and you can see I have a list of default tags here, but level parts is not in those tags. So let's make our own tag, click add tags, and we're just going to type here level parts. Now when I go back to the floor, level parts is in my list and I can select it. I'll also make this a level part. I'm going to make this a level part. I'll make this a level part. What else do I have? I have a bunch of stairs, and I could go through and do each of those stairs, but I don't want to bore you guys. Just a reminder in the future, it is a whole lot easier to set your tags as you're setting up the level than going back and doing them later, because then you can miss game objects and lead to errors, and well, it's just easier to do it in the beginning. But since we don't have too many game objects in here right now, I'm just going to set a couple of them to level parts. Alright, now I want to create the bullet hole, and I'm going to create it on this cube just so that we can see. And I'm going to first create an empty game object and pull it out to about there, and then I'm going to create a plane, and now I'm going to make this plane a child of that game object I just made, and let's resize that plane really a whole lot smaller, and let's set it to 0 so that it's in the center of the game object. Okay. And then one thing I want to do is I want to rotate it 90 degrees. Actually, I can't remember what axis I want to rotate it on. I think it's the Z axis. Yep. I want to rotate it around the Z axis. And now when we create our game, or when we create the bullet hole, it will be facing outwards. So right now you can't see anything because it's just blending inside of that cube. So let's actually put a material on that. Or actually, you know what? First, let's put that closer to the face of that object. Alright, now what we need is a texture of a bullet hole. So this is the texture I'm going to use. I made this in Photoshop in like 5 minutes, and it's really crappy, but it works for our purposes. So now let's create a material. And drag and drop that there. And drag and drop that there. And now it looks like we have a bullet hole, but there's actually a problem. This texture actually isn't transparent, and neither is the shader. So it doesn't look like it because in the lighting everything is gray, including the cube and the bullet hole. So I'm going to create a material just to show you. I'll just call this blue, and I'm going to set the color to blue. And now when I apply this, you can see that this bullet hole is still an ugly square. So to fix that, we're going to go to bullet hole and we're going to change it to particles multiply. So now the shader basically just makes things darker based on the image that you give it. And because the image that we gave it was black and white, and all we need for the bullet hole is to make things darker, we can go ahead and just use particles dot multiply. So yeah, now we have a pretty good looking bullet hole, and now our level is tagged. So the last thing we need to do is create a prefab for the bullet hole. And I'm just going to drag and drop that in there, and then I'm going to delete it. And now when I put it on something, we have the bullet. But as you can see, when I drag and drop the prefab right on top of the cube, it created it at the exact placement of this surface. So that there you can see the texture of the wall and the bullet hole mixing and how ugly that is. So that's why we need to pull it off the wall slightly so that we get rid of that. So that's why we have that code in place. So let's go ahead and delete that. And let's create our bullet script. So the first variable we had was max dist float, and I'm gonna have that equal a lot. I don't know what that number is, but it's a lot. Now we need decal hit wall, so this is going to be our bullet hole. And now we need float in front of wall, and we're gonna have this equal 0.001. There we go. Alright, now let's go into Unity, and we need to actually apply that to our bullet. So what I did, the bullet was a cube before, and then I just went over to here and clicked remove component on everything until it was an empty game object. And now I still have the same prefab, so when I go over here to gun and I click bullet, it highlights it, so it's still going to create this game object, but I just deleted everything inside the game object to start fresh. Now we need decal hit wall, which is this bullet hole there. And yeah, let's keep on editing. So what do we need first? We need var hit, and this is of type Raycast hit. And now we need our if statement with the Raycast function in it. So physics.raycast, and we need decal hit wall, and its origin point is going to be transform dot position, and its direction is going to be transform dot forward. And then we're going to save all the information inside of hit, and then we're going to have a maximum distance of max dist. Now you definitely want to count your parentheses, and Unity makes this pretty easy because when you, Mono Develop makes this pretty easy because when you click on any parenthesis, it's going, if it's an opening parenthesis, it's going to highlight the closing parenthesis. So if I click here, you can see this parenthesis is enclosing everything here. This parenthesis is enclosing everything here. And then when I click on the closing parentheses, it highlights the opening parentheses. And it does the same thing for brackets. So it's easier to find your opening and closing brackets that way. So now we have our raycast, and if that raycast actually hits something, we're going to run this next line of code, which is actually we need two lines, or we need another if statement. That's what I meant. Oops. So we're going to have if decal hit wall. So if we did create or set this to a bullet hole, and that's shift 7, our hit, so this is our raycast hit variable that we saved all of the information in, dot transform dot tag equals level parts. We're going to instantiate the decal hit wall at position hit dot point. So the point in 3D space where the raycast actually hit something, and then we're adding hit dot normal. So the magnitude vector that is pointing in the direction that the face is pointing, that the raycast hit, and then we're going to multiply that by float in front of wall, because we don't want it to float one unit in front of the wall. We want it to float a very small number in front of the wall. So we're multiplying that entire vector 3 right here by this number to make it very, very small. So it's just moving just a little bit. And then next we need the rotation of what we want to create. So quaternion look rotation, and it is just hit dot normal, because that is the direction that we want the quaternion to look. So let's just make sure I have the right number of brackets. I do. And now down here, I am done with the bullet, so I can just write destroy lowercase game object. Alright, let's see if I get any errors. I did. That means I probably spelled something wrong. Physics.raycast transform position transform dot forward. What did I spell wrong? Let me reread the error I got. Oh, I spelled instantiate wrong, first of all. Let me go over to my gun script and just copy and paste this. Control C. Oh, I forgot the S. Instantiate. Let's see if that gets rid of my errors. I'm pretty sure I'm still going to have one error. No appropriate version of the raycast argument list. Okay. Let me double check my source code here. Physics.raycast transform.position transform.forward. Yeah, isn't that what I have written? Let me go ahead and just copy and paste that line. And see, I must have typed something slightly wrong. Let's see what it is. Transform.position, transform.forward, transform.hit. What did I have before? Oh, decal hit wall. I don't know why I put that in there. That's what I did wrong. Whoops. Wow, shit. What am I doing? Edit, redo, Control Shift Z. Oops. Instantiate, and we're going to delete this because I don't know why I put that in there, because that is a raycast and we're not creating decal hit wall yet until we get down to here. We're just raycasting, so that was a mistake on my part. Let's see if that gets rid of the error. Instantiate. I'm still spelling instantiate wrong. So I'm just going to copy it from my other script where I know I spelled it right. And now let's see if I get any errors. There we go. Sorry about that, guys. Hopefully it works now. And it's not quite working, and it's actually lagging a lot. Okay, let me stop that. Okay, I think my first thing I got wrong. Okay, fire 15 bullets per sec, or yeah, 15 bullets per second. Now let's go to my bullet. Okay, now my bullet hole. Let's change the rotation of the plane first of all. So let's change that back to 0, and let's try rotating it along the x-axis. See if that looks a little better. It does. Sweet. Let me maximize this and play again. So sweet, I'm creating bullets, but it looks like they are too close to the surface. So let's change float in front of wall to 0.001. See if this looks better. It does. It doesn't look like it's mixing the textures at all. So yay, it looks like it's working. Creating some bullets. What's going on there? Is that just too many bullets in one spot? Yep. Wow. That really lags when you have a bunch of bullets on top of each other. So later on we're going to create some script that's going to destroy the bullets after a certain amount of time, because that lags a lot. Wow. Alright, well, this has been ETSK Tutorials FPS 1.13. Yeah, until the next episode, take it easy, keep making games. I'll see you guys later.